Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-3 for October-November 2023 for questions 5 to 7. Question 5. A light string AB is fixed at A and has a particle of weight 8 newtons attached to B. A horizontal force of magnitude P newtons is applied at B such that the string makes an angle theta to the horizontal. It is given that P is equal to 32 and the system is in equilibrium. Find the tension in the string and the value of theta. Okay, now here are the forces which are acting on this particle. Since this one here is a string, then there is tension which always acts away, okay, from the particle. Then I can extend this one here, and then also this one here, such that I make a right angle triangle. Now I'm going to resolve this T, okay. I can close it in here. That means I'm closing the angle. So this will be a cosine. So here, and since this arrow is like this, that means it is going to be facing up. So here I'll have closing is cosine, so T cos theta. And then when we open it up here, then it will be here. So which is parallel to this one. And it will be facing this side here, okay? So meaning I'm going to write this one here as T sine of theta. Okay, now since the system is in equilibrium, that means the horizontal forces are equal and also the vertical forces are equal. So horizontally, we are going to have T sine of theta, which is equivalent to 32. Okay, and then next for vertical forces, we are going to have T cos of theta, then is equal to the 80, which is going down. Okay, this is maybe equation 1 and this one is equation 2. I'm supposed to solve these two simultaneously. So when I get equation 1 and I divide it by equation 2, automatically the T will go. So equation 1 divided by equation 2, we shall get T sine of theta over T cosine of theta, which is equal to 32 over 80. Then this one will give us tan theta, which is equal to this one simplified by 16 we get 2, by 16 we get 5. Yes, then theta is going to be equal to the arctan of this 2 out of 5. So what will be that theta to 1 decimal place? Arctan of 2 out of 5. This one gives us 21.8 to 1 decimal place. So 21.8 degrees to 1 decimal place. Then I can substitute in any of the other two equations to get the answer. So I can say T is going to be equal to 32, then divide by sine of the answer we have gotten here, which is the arctan of 2 out of 5. Okay, I'm going to say here that 32 then divide by the sine of that angle. Okay, and close here just like that. Then we get 86.2. That is to 3 significant figures. So T is equal to 86.2 newtons. Just like that. Part B, it is given instead that the tension in the string is 120 and that the particle attached at B still has a weight of 80 newtons. Find the value of P and the value of theta. Now falling back here, we are having this diagram here. Okay, so this way we are having that P, this way we are having the T sine theta, then up we have T cos theta, and then the 80. So picking this one from here, and then we get, I can put it on the cross here that I always use. Okay, it's going to be that. So we are going to have 120 cosine of theta. Then we have 80 down here. Then this way we have P. And then this way we have 120 sine of theta. Okay. All right, because the tension was given as 120. That is the T. Now, horizontally, of course, like we have done before, horizontally, resolving the forces horizontally, we have P, which is equal to 120 sine of theta. And then vertically, we can see that 120 cosine of theta is equivalent to 80. So using this one, I can actually find the value of theta. So cosine of theta is equal to 80 divided by 120. And then theta will be equal to the arc cos of this one here. Okay. By 40, you get 2. By 40, you get 3. So what do we get here as the value of theta? Arc cos of 2 out of 3. This one gives us 41.2 to 1 decimal place. So 48.2 to 1 decimal place. Okay, then P, that means I'm going to substitute in the first one. So P is equal to 120 sine of that theta. And theta is the arc cos of 2 over 3, right? And then what will be our P here? So I'll have 120 sine of the arc cos of 2 over 3. And then we get 89.4 to 3 significant figures. 89.4. That is that. Question 6. A particle moves in a straight line at time t seconds. The acceleration a meters per second squared of the particle is given by a is equal to 36 minus 60. The velocity of the particle is 27 meters per second when t is equal to 2. Find the values of t when the particle is at instantaneous rest. So this is under variable acceleration. Therefore, we use differentiation and integration, not the other 3 equations of motion. Okay, those ones we use them when acceleration is constant. The v is equal to u plus at, s is equal to ut plus a half at squared, and also v squared is equal to u squared plus 2as. We use them when acceleration is constant. Now we know that acceleration is the rate of change of velocity, so it is dv dt. So meaning to get velocity from here, we shall integrate the acceleration with respect to t. Why are we integrating? Because they said at instantaneous rest. That means v is equal to what? 0. So v is going to be the integral of what we are given here, 36 minus 60, then with respect to t. So when you integrate here, you get 36t, then minus 6t squared over 2, that will be 3t squared. Okay, remember, you increase the power by 1, you divide by the new power, and then we shall put plus c, because we don't know the constant which was differentiated and it disappeared, for us to get a, which is equal to that expression. Okay, now they said that the velocity, they didn't say that the particle started from rest. They just say that a particle moves in a straight line. At time t seconds, the acceleration is given by this. Then they give you the velocity, 27, when t is equal to 2. So don't assume here that t is equal to what? 0. Now let us use this value of t given. Okay, you have said that t is equal to 2, then the velocity is equal to 27. So now substituting this one here, we shall have 27, which is equal to 36 times 2, then minus 3 into 2 squared. That's c. So we shall have 27 here minus 36 times 2, that is 72, and then 3 times 4, that is 12. So when it crosses, it becomes a plus to give us a c, and then our c here becomes negative 33. Becomes negative 33. So meaning the expression for the velocity here is 36t minus 3t squared minus 33. Now at rest, v is equal to what? 0, like I said before. So at rest, v is equal to 0. So I'll get negative 3t squared plus the 36t, then minus 33 is equal to 0. Okay, I can divide all through by negative 3, or let me factorize it. Here I'll get t squared, then here minus 12t, and then here minus, I think it will be a plus since I've taken the minus outside. So this will be 11, then is equal to 0. So the product is 11. Two numbers, when I multiply them, they give me 11. That is 11 and 1 because it is a prime number. And since the sum here is negative 2, that means this one will be negative and negative. So when you add them, you get negative 2. So meaning we shall have t minus 1 and then t minus 11, which is equal to 0. So meaning t is equal to 1 when I equate this one to 0. And then also t is equal to 11 when I equate this one to 0. So those are the two values of t when the particle is at instantaneous rest. I can even add on seconds. Then part B, find the total distance the particle travels during the first 12 seconds. Now, before you find the distance traveled by the particle, you have to always know the times when velocity is 0, and actually that is what they have told us to do here to find. This is 1 and 11. Now, the expression for velocity here is this one. Okay, it is this one here, where the coefficient of t squared is a negative. This is a quadratic expression. So therefore, we need to know when the coefficient of t squared is a negative, and this is a quadratic expression, then it is an N-shaped curve. Okay. Now, we need to know when t is 0. When t is 0, of course, v is negative 33. Now, this one is below the t-axis. You see that? Now, let's go back to what we are having here, the first 12 seconds. So, let me draw a simple sketch here. This is very, very important. Before you find the distance, first know the velocities, the times when the velocity is 0. Because when you do so, you will know which part is below the t-axis, whose area will be a negative if you just integrate directly. But you have to include the modular sign such that the part which is negative is now made positive afterwards. So when t is equal to 0, this is v meters per second. This is our time in seconds. When v is 0, we have seen it is, remember our v is equal to negative 3t squared plus 36t minus 33. So when we put 0 here, we get negative 33. So let me assume this is negative 33 here. And then velocity is 0 when t is equal to 1 and also when it is equal to 11. Now we need to find when t is now 12. What is the velocity? Okay. When t is 12, so negative 3, then put in 12 squared, then plus 36, then put 12, then minus 33. It gives us negative 33. So it is on the same line with this one here. Okay, that's with this one here. So I'm going to sketch this one. Of course, the turning point, the x-coordinate, is going to be between these 2 points where the curve crosses the x-axis. So 1 plus 11, that is 12, divided by 2. This one will be at, let's say, 6. Okay. Then maybe the turning point is around there. So we are going to have something like this. It is an N-shaped curve. Comes like that, symmetrical. And then we do like that. So that means this part which is below the t-axis, it gives us a negative area, and also this one. Okay. Now, since we are having only one expression, since velocity is equal to the rate of change of displacement, so that means that s is equal to the integral of v dt. So let me first integrate this negative 3t squared plus 36t, then minus 33 with respect to t. Increase the power by 1, divide by the new power. So we shall have here negative t, then cubed, and then plus t squared over 2. This one will give us 18t squared, and then minus 33 of t. Okay, so I'm keeping this one here. Maybe we can say plus c, but I have the limits. So my total distance, okay, the total distance is now going to be area under the graph. Okay, area under that curve, area under the graph. Now we are having the integral from 0 to 1. Okay, already I've integrated, so to save time I'm just going to put this expression minus t cubed plus 18 t squared minus 33 of t, then the limits are 1 and 0. Then this one has to be put in the modulus signs because it is below the t-axis. Okay, then plus we are going to have now 1 to 11. That one is above. I don't need to put the modular signs. So negative t cubed plus 18t squared minus 33 of t. That is from 1 to 11. And then lastly, we are going to put plus the modulus of negative t cubed plus 18t squared minus 33 of t. Okay, this one here, then put modulus. This one is moving from 11 to 12. Then we can put it in the modulus signs. Okay, then we can substitute these values here, and then what do we get? So when we put 1, of course everything is what? We shall now get negative 8, then plus 18 minus 33, then minus 0. Okay, then plus how about here? We shall have put in 11. So we shall have negative 11 cubed, then plus 18 times 11 squared minus 33 times 11. Then after we can subtract, and you put 1, which is negative 8 here, plus 18 minus 33, like that. Then plus, now put negative 12 cubed plus 18, 12 squared, then minus 33 times 12. And then after that we shall subtract when we substitute in 11, negative 11 cubed plus 18, then 11 squared minus 33, then times 11, like that. And then we need to put it in the modulus signs. So what do we get when we put this in the calculator? Actually here I'm having negative 1, not negative 8, negative 1. The same thing here, just to be negative 1, pardon me here, negative 1. Now we can put everything in the calculator. So what do we get? Negative 1 plus 18 minus 33. This one gives us negative 16. So you see that the area under the curve is a negative, so negative 16. And then we put plus. How about inside here? Negative 11 cubed plus 18, 11 squared, then minus 33, then times 11. That one gives us 484. 484. Then minus, of course, this one here, we got it as negative 16. So it will be minus 16. Okay. Then plus. How about when we put, of course, now I will put here minus. So this one here, we have gotten it up here. It is 484. Now when we put 12, what do we get? Okay, but under the modulus. So wherever there is 11, I'm going to put 12. Just to simplify this. Again, there is 11 here, I put 12. So that is 468. We have 468. Of course, 468 is smaller than 484. So you can see that it is also turning out to be a negative. And that is also negative 16. So this one is going to be positive 16 because of the modular signs. And then here, I'll add these ones together. They will give me 500. So 500. And this one is also negative 16. Okay. But the modulus turns it out to be a positive. That means altogether When we add these, they give us 532 meters, just like that. Question 7. Particles A and B of masses 2.4 kilograms, 3.3 kilograms respectively are connected by a light inextensible string that passes over a smooth pulley which is fixed to the top of a rough plane. The plane makes an angle of theta with the horizontal ground. Particle A is on the plane and the section of the string between A and the pulley is parallel to the line of greatest slope of the plane. Particle B hangs vertically below the pulley and is 1 meter above the ground. The coefficient of friction between the plane and A is mu. Then part A, it is given that theta is equal to 30 and the system is in equilibrium with A on the point of moving directly up the plane. Show that mu is equal to 1.01. Okay, to 3 significant figures. Now, let us look at the forces which are acting on these particles. This one has gotten weight, okay? It has gotten weight here, which is 3.3 G. Then there is also tension generated here in the string to make it taut. It always acts away from the particle. Even here, it is the same tension, okay? And then here there is mg cosine, so 2.4, then the cosine of theta. And then down here, we shall have the mg, 2.4 g, then the sine of theta, the horizontal component of the weight. So since the particle is on the verge of moving directly up the plane, that means the frictional force is acting downwards. So here we shall have the mu r, okay, acting downwards because it opposes the motion. And then here we shall have the normal reaction, okay. Now, we are going to look at now these forces in particular. So since it is in equilibrium and also we don't have the vertical motion perpendicular to the plane, so r is going to be equal to the 2.4 cosine of theta, but theta is given as 30 degrees, okay? That is root 3 over 2, so 2.4, then times root 3 over 2. This one here will give me 1.2, then root of 3. I can leave it there. Then, when we look at the forces acting on B, okay, on B, the tension, this one going up here is equal to this one going down, okay? So we shall have T, which is equal to 3.3 G. So that is times 10, so T is equal to 33, okay, newtons. Then, let's look at the ones that are acting on A, okay? We shall have the tension, which is equal to now the mu r, and then plus the 2.4 G, then sine the angle, which is 30. So, remember we are supposed to find mu. So meaning, since we have gotten our T as 33, so I can put here 33, then minus the 2.4 times 10. Okay. Oh, I think there is something that I forgot here. Pardon me. It has to be, there is a 10 which I forgot here. 2.4, because it is mg cosine, the r, 2.4 times 10, okay, cosine. So this is therefore 24 here. I'll have 24, and then this will then give us a 12 here, okay. That will be a 12 root of 3. So that means I'm going to have 33, then minus 2.4 times 10 here, then sine of 30 is a half, okay. Then this one will be equal to mu r, and the r is 12 root of 3. So meaning mu is going to be equal to 33, and then 12 divided by 2, that will be 12, so minus 12, then out of 12 root of 3. So what do we get? Is it the answer they have told us to find? So we have 33 minus 12, then divide by 12 root of 3. 12 root of 3. It is that. Okay, 1.01. 7 root 3 over 12. 7 root of 3 over 12, which is equal to 1.01 to 3 significant figures. Part B, it is given instead that theta is equal to 20 and mu is equal to 1.01. The system is released from rest with the string taut. Find the total distance traveled by A before coming to instantaneous rest. You may assume that A does not reach the pulley and that B remains at rest after reaching the ground. Okay, now when when B reaches the ground and it stays there, there is going to be a smaller distance which is traveled by A on the plane, and then the tension in the string goes off because the particle here, the string would have become slack on the side of B. Okay, so this is our sketch. I can put it here. Then this is the pulley. So we have the particle B here. Then by the time it comes and then sits on the ground, now the string becomes slack when it is here. Okay, so that means the tension here is 0. We have our particle A here. It is on a rough plane, that is mu r. Then here there is mg sine. So they have given us the angle is now 20. So mg, that is 2.4 times 10, that is 24. So I can write 24, then sine of 20 here. Of course, here there is 24 cosine of that angle 20. Then here we have the r. Okay, now this particle A, it is connected to this pulley here. This particle here moves this distance up here. When B, remember B was 1 meter, okay, 1 meter from the ground. So when B moves a distance of 1 meter, then even A has moved a distance of 1 meter up here, okay, 1 meter. Then it continues to move a smaller distance when B reaches the floor and the string becomes slack. So that means there is a smaller distance traveled here, which is x. Okay. Of course, we know that there is tension in this string. And here there is also tension, but then it goes away. Okay. But here it was there at first. Now that means we need to find the acceleration for the first movement here. After finding that acceleration there, we need to then find the speed with which B hits this ground here. Okay, it will be the same speed with which A is moving when it reaches here. Okay, then that acceleration we are getting, it is the one which helps us to find the speed here. Then from there, since when B reaches down here, the spring becomes slack. That means that the potential, the tension has gone. So tension is 0. And then there is now a new acceleration here. It is actually going to be a deceleration because the particle is coming to rest. Okay. So we need to get a new acceleration for that one when T is not there. All right. Then B here, let's look at the forces which are acting on B. Remember, we are going to use F is equal to MA. So on B, we are having 33. Okay. On B, this is 33 here. It is 33 because here I have 3.3 G. Okay. 3.3 G, the weight. So that's why I'm writing 33 here. In fact, let me include it here. 33 newtons. So 33 then minus the tension then is equal to the mass of B is 3.3 then times the acceleration. And then we go to what is happening on A. We have this T here. So T minus the frictional force, which is mu r, so 1.01, and then our r is of course equal to this 24 cos 20. So I put here r is equal to 24 cos of 20. Then after that, there is also mg sine 20. So 24 sine of 20, and then we shall equate to 2.4 of a. So when I add these two, this one will disappear, the tension will go. That means we shall have 33 here minus 1.01, then times the 24 cos of 20 minus the 24 sine of 20, okay, which is equal to 2.4 of a. So meaning I'll get whatever I have on the left here, and then I divide it by 2.4. So 33 minus 1.01 into 24 cos of 20, and then minus the 24 sine of 20. Then we divide by the 2.4. So what is that acceleration there? Okay, so we put everything in the calculator. Now I have 33 minus 1.01 into 24, then cos 20, then after that close this bracket, then minus 24 sine of 20, close the bracket. I come down, divide by, no, this is not 2.4, by the way. We are adding, so 3.3 plus 2.4, 5.7. So pardon me here, this is 5.7, 5.7. So that is what I'm going to divide with. So 5.7. Then we get all of those figures there. 0.353, and the rest of those figures 0.35322, 235, and 6, maybe 55. That is meters per second squared. So I can first keep that there. Then we need to find the speed of this particle when it reaches the ground, when B reaches the ground, which will be the same speed at which A is moving. Okay, so we are going to use V squared is equal to U squared plus 2AS. So that final speed is going to be the square root. The system was released from rest. So that is square then plus 0 square then plus 2. There is an S here. Acceleration is this one, which we have gotten 0.353, and the rest of those figures, then times the distance traveled is 1. Okay, the distance traveled is 1. We can go back and check for it. Okay, 1. You can see B traveled a distance of 1. So here we get a value, a certain value. Okay, so I can just leave it as the square root of these 2 times 0.353 and the rest of those figures. Okay, let me just leave it there. Then after that, let's look at now the final movement when the tension is equal to 0. Okay, when the string is slack, that is after B reaching the ground. Okay, reaching the ground and remains there. Okay, so that means tension is equal to 0. Now coming back here, using the forces which were acting on A, okay, we are having now 0. We are using this one here. The tension is not there. So we shall have 0, because now we are using F, of course, is equal to MA. Now 0 minus the 1.01, then 24 cos 20, then minus 24 sine 20. Then this one is equal to 2.4a. So meaning acceleration, you see that it is going to be a negative 1.01, then the 24 cos 20 minus the 24 sine of 20. Then we divide by the 2.4. We can have negative 1.01 into 24, then cos of 20, then after we subtract 24, sine of 20. Okay, then down here we have 2.4. So it will give us negative 12.911. Okay, so I'll take acceleration is equal to negative 12.911. Okay, and the rest of those figures, meters per second squared. That is the new acceleration. Now using v squared is equal to u squared plus 2as. What is that extra distance traveled by the x when it is coming to rest? So because it is coming to rest, then the final speed is 0. And then the initial is this one that we got here. Okay, so I'll get 2 times that 0.353, then under the square root. Of course, now we square it. Okay, so that is that, and then plus 2 times our a, which is a negative. It is expected to be a negative because the particle is decelerating, it is coming to 0. Okay, so what is that? X. Then I can have this one brought this side, it will be a positive. So we shall have 2 times that 12.911 of x, which is equivalent to 2, then times 0.353. Okay, yes, then x is going to be, don't you think that this 2 actually goes? So we shall have 0.353, then divide by the 12.911. So what we get there? 0.353 divided by 0.353 divide by 12.911. We get 0.0273. Okay, 0.02734, 0.02734. So meaning total distance traveled by a, total distance traveled by a up the plane is going to be equal to the 1 meter it covered when b was moving down, then plus this one we have gotten 0.02734, but we shall write to 3 significant figures. We shall have 1.0 then 3. Okay, 1.03 meters to 3 significant figures. So that has been it for this last part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, please like, share, and even subscribe. See you in the next videos.